To time travel, we need to understand a few concepts. We also need to understand the only way to travel to the past is to exist in the present, because anything you look at is somehow delayed through the finite speed of light. Let's start with part 1. Part 1, relativity. I'm going to make this a lot simpler than it needs to be. Relativity in one sentence essentially states that everything in the universe is relative to its observer. Speed, time, and spatial distances. None of them are absolutes that rule the universe in one uniform fashion. Rather, they are flexible, movable, and manipulatable. Here's a very simple example to understand the concept of what I'm saying. Statement 1 is speed is relative. Let's say you're on a bench with a motion through space as 0. Essentially, you're at rest sitting on a tiny bench. Now let's say that a car passes you at about 50 miles per hour or 81 kilometers an hour. That car is subjectively going 50 miles per hour. But why? Well, let's say you're on a bike instead of at rest traveling at 25 miles per hour. Now when the car zooms by you, it is traveling 25 miles per hour relative to you, meaning you'd observe it as though you were at rest and it was traveling just 25 miles per hour. Now that seems intuitive, but most people don't grasp that that concept applies to almost everything in the entire universe. Einstein in relativity stated that space and time are not separate entities, but rather one and the same thing. Part 2, gravitational time dilation. Let's move to actually traveling through time since we scratched the surface of general relativity. The biggest assumption for gravitational time dilation is that for any object, the laws of physics, mainly the speed of light, remain the same. Light has a constant speed of 300,000 kilometers a second, and no matter if you're on Earth or across the universe, light still travels at that speed. Even if light is launched off of an object that is accelerating, it still travels at the same speed. Its distance is just cut. If Earth was at rest and we beamed the laser off of Earth into a location in space, that light would travel to that location in a certain amount of time at its constant speed. Now if we assume Earth was moving at its normal speed around the sun towards the location we are beaming our laser, then light itself does not slow down because Earth is accelerating it. Instead, it leaves Earth at the exact same speed and simply travels a shorter distance to reach the point in space. Now that we understand that the speed of light does not change but rather travels greater or shorter distances, we need to define what a second really is. 1 second of time is the exact same locally for any observer in the universe. Whether you are on the event horizon of a black hole or on the surface of the Earth, the second that we count inside of our heads is the same exact value of time passing by for both of us locally. 1 second is technically defined as 9,192,631,770 periods of the radiation corresponding to the transition between two energy levels of the ground state of a cesium-133 atom. That's a whole lot of incomprehensible nonsense, but what that means is a second is defined by essentially the reactions of atoms that happen locally. If you're on Earth, when you count 1 second, this definition of a cesium atom transitioning has occurred. If you were on the surface of a black hole and did the same amount of cesium atom transitions have happened. The distinction is that those reactions on a black hole relative to Earth are happening astronomically slower. Chemical reactions are inherently governed by the geometry of the space-time around them. So if the reaction from A to B takes 10 seconds on the surface of a black hole, it will feel like 10 seconds locally, but outside of the gravitational bounds of the black hole, it may feel like hundreds or millions of years. In conclusion, it's not simply that reactions slow down in gravity, it's that all chemical processes define time locally, and gravity changes how long those reactions take to occur due to the curvatures of space-time. That is gravitational time dilation. So to travel to the future, you need to simply travel dangerously close to the event horizon of a black hole, and when you look up, you'll literally see a time lapse of the universe occurring. There's one more way to travel to the future though, and it's with the same method but in a different medium. Part 3, speed time dilation. Travel to the future. Speed time dilation is as simple as the name. Travel at a faster and faster speed, and you begin to move through space infinitely more than through time. Let's create two variables. One is m for motion through space, and one is t for advancement through time. M equaling 0 would be an object is at rest. An object at rest is moving through time at the maximum possible amount, meaning the definition of a second would pass quicker for you than any other observer relative to you. Earth itself still experiences an extremely negligible amount of time dilation because of its rotation, movement around the sun's movement around the Milky Way, and the Milky Way's movement towards the Great Attractor. The speed of light is the maximum distance of an entity in the universe. Just like we gave an example of an object at rest through space, that same example is possible when an object is at rest through time. This is because space and time are two of the same thing. They exist together and are intertwined in their methods of working. If you are moving at the speed of light, your m variable is at its absolute max. That means that your t variable needs to compensate for that inequivalence in some way. Thus, moving at a velocity as enormous as the speed of light would cause your t variable to equal 0, hence you would experience no movement in time locally. But of course that's not possible for an object with mass. From an Earth observer, however, eons and eons would pass for them while you exist at the speed of light for simply an instant in your perspective. Also, if time is now moving locally for you, everything that occurs at the speed of light for the observer is happening instantly. A human mind can't comprehend that idea that absolutely zero time has passed and the entire universe will exist at an instant. If you were to achieve the speed of light though, you could literally travel to any moment in the universe's future, but be careful in doing this because you can never come back.